All right, hello everyone. Welcome to the fabrication and prototyping presentation that we have for you guys today. We'll be presenting about what exactly is prototyping and just overall the importance of it. My name is Carolyn. I'm the moderator for today. I'm a mechanical student on 1678, and our two presenters here are going to introduce themselves, and they're the ones who put together this lovely presentation for you guys today. So let's start off with Zatara.
Hello everyone, my name is Zatara and I'm also a student on 1678. I'm on our hardware fabrication team and I've done design for the past 3 years. I'm also 1678's hardware fabrication lead.
I am Devin Castellucci. I have been a part of 1678 for, I believe, 14 years now. I am the fabrication mentor for the team, and now we're going to go ahead and get into our first slide.
Yeah.
For sure.
And
Yep. All right. Just a notification for everyone in chat. A lot of this presentation is based on the questions that you guys have to ask for us. So in the back of your mind during this entire presentation, just write down some questions you've got because we plan to answer them after the kind of, presentation-esque parts, right? So first slide, thank you, Carolyn. Let's just ask the obvious question and get this out of the way real quick, right? Might ask, what's a prototype? And to answer that, prototyping is a rough construction of an idea or just a mechanism that you want to, well, test, right? The purpose of the prototype should be of that, being able to make quick iterations and changes in some variable to find a design that works the best or most efficiently for what you're trying to, achieve, right? So after you've finished prototyping something up, you take those important findings from that, right? Whether it be some dimensions or in general just how to go about implementing something in a robot, and you just kind of get that turned into the, real deal, right? So I guess some way a team could go about that is by, getting it into the CAD, getting it manufactured, and then obviously getting the mechanism assembled and fabricated and put onto the final robot, right? And then just another thing I like to mention for prototyping, get very creative, right? Your prototype doesn't have to be expensive, and what's important is that you get the insight for what you need, right? A lot of stuff that we use on 1678 are basically a absolute ton of scraps, right? And you'll see us reuse parts from our robot, such as drivetrains or shooters. We'll show you in some later slides, right? And we've also got some other stuff up our sleeves, such as 80/20, right? If you don't know what that is, it's basically like Connects or Lego for FRC students or just anyone in the professional industry, where you can make some really, 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 really quick assemblies with these kind of aluminum tubes, right? And which are very super easy to connect together. We've also got lumber. Lumber is our absolute best friend. It's really cheap, super strong, and it's just very, very easy to cut, right? This year, and additionally, we've also found ourselves prototyping with some laser cut wood. We got a laser cutter in the past year, so we can basically cut anything thin, very quick, and it's at your disposal and very perfect for prototyping, right? And then just to finalize the definition on prototyping, make sure it's suited for your robot's needs and what you're trying to just get out of the prototype. It's vital that your prototype is efficient and effective because essentially your robot will be your advanced prototype, right? With your final robot, you're going to spend a lot of time optimizing it and iterating on it so that it can perform its best during competition, right? Now, your next line will be what is considered effective, right? Well, that's just figuring out the things that your prototype can do and what it cannot do. Basically, what works and what doesn't work, right? Kayla, could you go back to the last slide for a quick sec? Yeah. And then just this picture on the right side, I'd like to mention, I want to talk about this photo, right? It was our cargo intake prototype in 2019. And you might ask yourself some key takeaways, question mark? Well, if you take a look at it really closely, it's A, extremely elementary, and B, it's super easy to iterate upon, right? This prototype is made completely out of wood, and it's very obviously tossed together, right? On the hex shaft, you can notice that you can power it with a drill, and you've also got you've also got the option to switch out what types of wheels that you can use. And notice that there's actually 2 screws inside of the lumber, setting the height of how far the wheels are off the ground, right? So with this kind of variability and just ability to iterate, you can use this information to, I guess, figure out the optimal compression when intaking a ball, right? And then I believe on our actual robot that we actually decided to go with full mechanism wheels, so that when we touch the ball, A, we own it, and B, the ball will be funneled toward the kind of center of the mechanism, though, right? All in all, it's a very simple prototype, and it's not really complicated, right? All right, next slide. On this slide, you'll find a bunch more prototypes that we've had over the past few years, right? And starting from the left side image, here's a prototype from our intake from our 2018 robot, right? Notice how the drivetrain is straight up, just a simple kit of parts drivetrain. That's basically reusability at its prime, right? And then I believe for that specific prototype, the important factor for designing this intake was kind of figuring out where the wheels should go in respect to the power cube, right? And check out that basically take a look really closely, that the only thing determining where the holes are on that wood are those pieces of plywood that are attached to the ends of the arms, which are,
Caroline, can you go ahead and full screen this?
Plywood's very easy to, I guess, replace and put some new hole arrangements on that, right?
There we go.
And then,
Really easy to see.
Let's take a look at the middle image now, right? Next up, we've got our kind of a hatch panel intake from 2019, right? And the purpose of this guy was to just figure out the right shape for the beak that could, I guess, expand and grab a hatch panel from the inside. And then this prototype also tested a method of releasing it, right? Big takeaways here is my favorite part about this prototype is the fact that we're using a drivetrain from our 2018 practice robots, and that the structure used to, I guess, lift the mechanism off the ground is some very obviously whipped together pieces of wood, right? And then lastly, if you look on the right side, we've got another prototype from 2020. Carolyn, would you like to talk about this one for a quick sec?
Yeah, so if you can actually see the person on the left working on the prototype is me. Basically, this prototype was from 2020, so we had the fuel cells, and we were testing a new different type of funneling system. So we were trying to decide between this funneling system where it had 2 belts at the bottom, one was faster than the other, and it would feed the balls up into a column, which would have the shooter on top, versus the spindexer, which we ended up going with, which was basically just like a huge circle, and the balls, and it would spin super duper fast, so the balls could find a place in there, and then when we were ready to shoot, it would spin again, and all the balls would be able to be released. So this actually just goes to show that we boiled it down to 2 ideas that we had, and we ended up without deciding which one we wanted to go with. So we ended up prototyping both options to see which one we'd like better, and we ended up actually going with the spindexer on our final robot. But this just goes to show like the importance of prototyping. You can test if you boil it down to a lot of boil down from a ton of ideas to 2 that you can't decide on. Like testing it in action really can show the benefits of each system.
Awesome, thank you, Carolyn. All right, I think we're ready for the next slide. So basically, right, now that we've got some examples out of the way and introduced you guys to the importance of the purpose of prototyping, let's talk about some of our philosophies that we go by on 1678, right? And then the first and only one I'll take out of this happens to be my favorite, but I highly emphasize is fail faster, right? Nobody, especially us, we never usually get things right on the first try. And then realistic situations, or just, I don't know, life in general, it's very difficult to predict, right? And what I mean by this is fail faster in order to succeed sooner, right? Experiment with your prototype under any circumstances, and very especially the ones that will make your robot fail, right? This goes for your completed robot, but by figuring out what works and what doesn't work on your prototype, I can guarantee that your robot will come out better if your team knows your mechanism's full capacities, right? And I think we'd all love to go to a competition, being completely prepared for any situation that can happen. So by failing faster to succeed sooner, this is one step towards that, right? I'd also like to mention, do your best to prototype during unideal situations, right? Competitions are, you know, real life and are usually wild. And during a match, your robot will not be in an ideal situation during a match, right? A disclaimer of that, of course, is ensure that you do your best in those situations that aren't ideal, but don't really be surprised if something comes up, right? During your testing, if a robot only works under X conditions and not YZ conditions, try to think of some methods of how it can, work under all X, Y, and Z conditions, right? Anything else you'd like to mention about this, Devin?
Yeah. So, one of the biggest things that I see a lot of teams do at competitions, particularly at the practice field, is they will very heavily baby their robot. So what that means is if they're going to go intake a ball, they'll put it directly in front of the robot and make it super easy for the driver instead of forcing them into a position where they have to actually work to get the ball like they would during a match. So it's really important to sort of have this philosophy that you want to make it difficult for both the robot and your operators in order to acquire game pieces and score them, because the more experience you can get on that and see, okay, it's really hard for us to pick a ball up against the fence with this intake that we have, right? So do we want to try and design the intake so it's better at picking balls up against the fence, or do we want to change our strategy and be more along the lines of, okay, now we need to skim along the fence so we can knock the ball out into the field to make it easier for us to acquire, and approach it from that way. So it's a give-take choice that you can make in, are you trying to solve something with how you're driving and strategizing, or with how you're designing. And it's an important step that you need to be taking with your prototypes to determine how you're going to approach those choices. Yep. Go ahead and
Awesome.
hit the next slide.
I think that was a perfect way to phrase it. Thank you, Devin. All right. So basically, now that we've got our philosophy out of the way, let's get a little bit into how we prepare our students to kind of master the art of prototyping, right? So every year during our off season, our team loves to hold these challenges, or sorry, short competitions, which we call prototyping challenges, right? So these are 2-day processes, which encase obviously a short competition, in which student teams, including both veteran and new, are given a very simple challenge with a limited number of supplies and restrictions, right? Basically, rules, right? Just to clarify, I'd like to mention that our team meets every Wednesday and Thursday evening for a tiny bit of 2.5 hours every week, right? So kids will spend the first half of their first day to kind of discuss how they would go about their prototype, and then I guess the rest of their first day and a majority of their second day will actually be dedicated to building their prototype, right? And then finally, on the second day and kind of like the last hour, we'll be playing the challenge, right? So prototyping challenges are a really great way to introduce prototyping to new members and kind of sharpen your kind of MacGyver senses, right? Or the ability to kind of whip something up legitimate on a whim, right? The challenges that we give out aren't really insane, and I believe they're pretty healthy, in which we kind of reuse the game objects from previous years, right? Carolyn, could you go to the next slide for a quick sec? I think my favorite example is that of the fuel from 2017, right? After Champs 2017, I have no idea what a team would do with 10 million wiffle balls, right? But prototyping challenges is kind of the best example we've got for them, other than, I don't know, food, right? So the challenge shown here was us playing Hungry Hungry Hippos, right? With the design challenge with the challenge to create or prototype some form of intake to suck up as much fuel as possible in a given time limit, right? So basically, what we do in the off season is, I like to reiterate, is have these prototyping challenges to practice and just kind of get everyone's senses going for when actual build season kicks in. Is there anything you'd like to mention on this slide, Devin?
Yeah, so one of the biggest things to note here is that most of these are wood and plywood prototypes. The one on the left, with Zatara working on it, you'll notice that the intake that they're using is being powered by a drill. This is something that's very typical of our sort of first approach, because it's real easy to actually control speed with the throttle on the drill. It can't generally get quite as high as motor power in terms of rotational speed, but it's really quick and dirty easy to do. Um, now you'll notice both of these prototypes are being pushed around, because that was not a part of the challenge. It was just make something that can pick up as quickly as possible and contain as many as possible of the fuel in a given period of time. Now, the one on the right, you'll notice, is actually being powered by some motors. So this is a little bit more advanced prototype. This was something that we had planned ahead of time to be done. Now, 1678 likes to have prepped a number of motor gearbox combinations for our more advanced prototypes in the start of our seasons. And then if we actually come across something like a shooter that we need to prototype, we generally actually require some form of feedback control so that we can get a target speed. And in those instances, we'll actually rope in fully the electrical and programming team in order to set up a really basic robot. Honestly, sometimes it's just the speed controller necessary and hooked up to a previous drivetrain, and that's it, just because it's already got most of the wiring hooked up. So that's sort of the three-step prototyping process with various levels of motor control. You have level 1 with just use a drill because it's quick and easy. The next one is just control the speed with a gearbox and then supply it power with some choice of motor. And then the last choice is, okay, we actually need to fully have control over the speed with the motor so we know how fast it's going and it's able to achieve a target velocity, which is a lot more advanced, but some prototypes do require this to be successful. So let's see. Go ahead and go back to the slide to see if there's anything else we missed. And the other thing I wanted to mention is these prototyping challenges are a fantastic way to introduce sort of basic hands-on skills with your tools that you use. So it teaches your students how to use a drill, how to use a handsaw, hacksaw, how to properly drive a screw in without stripping the head out. I think that's one that a lot of people commonly underestimate. It's like, oh, it's just driving a screw in. Yeah, you got to push pretty hard to make sure you're doing it right, and it takes people a little time to get a proper handle on a lot of these basic tools, and these challenges give them a lot of experience with that. And this is one of the primary ways 1678 introduces these, okay, you need to utilize all of these basic skills that we've trained you to do and you need to do them quickly. And that's sort of the key. It puts a nice big time crunch on them, so that they are actually forced to just get it done rather than doing it well. Because prototypes are about extracting as much information as quickly as possible, learning from it, and then moving on. So go ahead and jump forward 2 slides.
All right. So then, of course, there's off season, and then we have everyone's favorite part of the year, build season, right? Things get a bit more sophisticated, but our heart and mind, our prototyping mind, are going to stay kind of the same, right? If it's all right, I'm just going to go into a quick, very, very quick crash course on how 1678 does kickoff, and I'll just go right into it, right? On day one, 1678 watches the game reveal together, and then everyone takes a long time to kind of read the rules and envelop the rules, right? Just by spending some time individually. And I'd like to add on that this includes all of the members on our team, from mentors to students to, I don't know what other people there are, but everyone is going to read those rules, right? In the meantime, right, while everyone is kind of reading the rules manual, our leadership team will kind of speed run it and write up a quick rules test to administer to all of our students and our mentors, right? And we basically ensure that everyone passes this test with a really, really high score, just to make sure that everyone is kind of on the same page, right? So this kind of goes all the way until, I want to say, about noon, right? And then, as you guys know, kickoff is always on a Saturday. So we spend the rest of that Saturday discussing with the entire team on kind of strategizing the goals that 1678 wants to accomplish, right? And we call this kind of session our what brainstorming session, right? What we want 1678's robot to do, right? On the second day, or Sunday, we kind of wrap up the what brainstorming session in the morning, and then our technical sub teams break from the non-technical sub teams, right? So that those technical sub teams include like programming and hardware and electrical, and we kind of get into the how brainstorming session on the second day, right? So now that 1670 as a collective team has kind of figured out what we want to do with our robot, we delve really into the how we want to accomplish these goals, right? And then on Monday, um, I'd also like to mention that usually people have school on Monday, but our district is very fortunate in giving us vacation on Monday because it's just right after spring break. This is for every year, right? So basically on this Monday, we use this to our full advantage and getting straight to the prototyping for the rest of the week, right? Now you may be asking, what do we actually prototype? And after we figure out our hows and kind of after we figure out our whats and kind of discuss some hows, we usually have a few ideas that we want to test out. So we break on Monday into some prototyping teams that will start their work Monday and full send it for the rest of the week, right? I'd like to mention that before we go to the next slide, the image to the right is an example of what we wanted to try out in 2019, right? So in 2019, as you guys know, there was these hatch panels, these kind of discs that you could pick off the ground, right? So we just wanted to try making a prototype where we could, grab a hatch panel off the ground, and we call this our hatch panel intake, right? And while it was arguably successful, we chose to remove it off the final robot to A, save some weight, and B, we realized the fact that it was probably faster to grab a dropped hatch panel from the driver station rather than picking out the ground. And let me remind you, there's a reflector tracking tape on the driver station. So we decided to go with no ground hatch panel intake, right? Basically, in the end of all this stuff, though, I'd like to mention that this mechanism disappearance was not in vain, because A, we learned of a very effective way to pick up hatch panels, and B, it was basically another tool in our toolkit to take note of for the future, right? So big important thing to take away is that we wanted to test a prototype, so we did test it out, and we basically decided later if we need it or not, right? I think that's good for that prototype.
Yeah, one of the
Right.
the big upsides to doing these prototypes it helps build your team's institutional knowledge, sort of the living memory of the team. Is one of the good things about having experienced mentors that have been with a team for a while around, is they can remember what's sort of worked for the team's resources in the past, and what will be easy to implement going on in the future for various challenges. So with this particular prototype, we sort of used what we learned from the 2013 season with picking frisbees up off the ground, modified it slightly because of the difference in shape for the hatch panel, and then we went, okay, how are we going to pick up this thin, flat, hard object? And we're like, okay, we need to scrape it up, and then we need to sort of clamp it so we can lift it up. And this is what we came up with. And even though we didn't use it in the long run, we still learned a considerable amount about how to approach the challenge of picking up that style of piece. So it's still always valuable information. Even if it doesn't necessarily work for you, you learn what does not work for you. So we can go ahead and move on to the next slide.
Yep. So on this slide, it's basically just a bit of logistics for how we actually break into our prototyping teams, right? We basically prototype every single year about, I want to say, 4 to 6 different mechanisms. And what we do is we choose student leads to lead other students and ensure that this prototype reaches its fullest potential, right? All the way from getting prototyping tested to CAD, basically all the way up to competition, right? This lead is usually the lead designer of the mechanism, but it doesn't have to be that way. It doesn't have to be a designer, is what I'm trying to say. And basically, we make it the job of that lead or that prototyping lead to make sure that they carry getting this made all the way up to competition, right? And then if they're not a designer, same rules apply. They just got to work really closely with someone who can CAD it, and they'll basically communicate what needs to happen in the prototype for it to become a mechanism and get placed onto the robot, which will continue to be iterated on the actual robot until competition date, right? So I think what I'm trying to say is that for prototyping teams, there should be some lead that will be responsible for taking this prototype to be iterated as much as possible and optimized all the way until competition, right? Then obviously you'll sprinkle in some, design members, fabrication members, electrical students, basically a good balance to that everyone has kind of same resources at first. And it's fair to say that you're allowed to, I guess, redistribute those resources as you need later in build season, right?
At the beginning,
And then
it's a fairly rigid thing, where it's just these are all of our teams. But as the season progresses, it does loosen up, and people will very commonly start to get reallocated as the needs of each prototype becomes more clear. Go ahead.
mm-hmm. Yeah. And then some other information to take away is that document literally every piece of information that you can about your robot. As you guys probably know, a prototype is being worked on in person, and when your CAD designer goes back home, they probably won't remember every single detail that occurred during that meeting, right? So on 1678, we highly emphasize that while you're prototyping, record absolutely every piece of information, whether this be, I guess, videos, just to make sure that the CAD person understands, the actual process that's going on, or even just measurements or other notes that you like to take out, like say maybe use these types of mechanism wheels, or just use these kind of wheels in general, right? Take a ton of documentation, and then of course there's the obvious things that you should take note of. Know your parameters. If you're, say, given a amount of space designated to you on the robot, make sure that you don't build your actual mechanism bigger than that, right? Make sure that your mechanism will be able to, I guess, work in that amount of space, right? And then if you look at the middle bullets under the documentation and methods, the best designs are those that are narrowed down and further perfected. Basically, another way to say optimize until competition day, right? Anything else you like to add on for that, Devin?
So it's really important to make sure you're documenting. Every time you're doing a test, you should be taking a video so that you can review it and see exactly how it worked. You should always be testing different ways. You don't want to have it say intake a ball directly from the front every single time. Do it from the sides. Test it where the robot would be twisting across. Every single different way you can have it interacting with your game pieces. And then you want to be taking all of the measurements required so that you could take all of the documentation that you've built up, give it to someone, and then they can replicate it again, either potentially as another prototype or as an actual mechanism that it will now go onto your robots. Yeah. Go ahead and next slide. So this
All
is
right.
our parts tracking sheet, and Zatara is going to explain how our students manage keeping track of all of this stuff.
Yeah, for sure. This is a question that gets asked every single year. How does 16 or what is 1678's actual, I guess, process for getting something prototyped to actually getting designed to actually getting fabricated, right? So this is the spreadsheet we use. It's a single spreadsheet, right? And what will happen is the designer of a part will just, you know, list it down in this huge, gigantic list of what we call our parts tracking sheet, right? Basically, they'll when they add this information or add a part number, right? They'll add some information such as the designer, so that in case if there's something wrong with the part, the designer, sorry, the someone can tell the designer what's going on with this part. They'll also give it a bit of a description. We basically these are just kind of names, right? But it's helpful for in case no one remembers the number 1678 part 0613 off the top of their head. So what you'll do is you'll refer to the part tracking sheet and you'll just take a look at this part and be like, designer, I remember what this part is, right? Some also other information we take note of on the part tracking sheet are what machine this will be run on. This is helpful for the fabrication lead to kind of take note of maybe like what machines I'll designate this day. There's some other information which are, I guess, pretty essential, such as quantity of how much parts you'll need, if there's a second batch needed. There's also numbers for those. It's just currently not on screen. But yeah, all the information that you basically need on for a part tracking sheet, right? This is just how we track it. And then you'll notice that there's these things called statuses. We can change this from like part needs a part drawing or part needs a toolpath. You can change it for like ready for router, ready for QCing, and of course there's the final status, which we always want, which is this part is complete, and that's shown by the green under status, right? We also like to keep track of what machinist actually, machine the part. I think Devin can go a bit more into that later of why that's so important. But
actually, I can go ahead and do that right now if you want. So,
go for it.
It's super critical that the process actually has someone accountable for who made the part drawing, who made the part. So in the case of who made the part drawing, if the person that now needs to make the part is unsure about something, they know exactly who to go to ask and be like, these dimensions are kind of laid out poorly. It's hard to figure out what exactly is super critical. So what do I need to do in order to make this part properly? So that's one example. The other example is what happens if a part ends up being machined to something out of spec. So if they messed up a dimension somewhere, we need to be able to know who made the part so that we can go, okay, why did this end up getting made incorrectly? So that we can then address that student and be able to go, okay, this is how it went wrong. This is what needs to happen the next time you do this. I personally don't care if a part gets messed up, but it really annoys me when I'm not able to figure out who I need to teach more. Um, so that's one of the things we do on the part drawings is there is a spot for who made the part, and the way I finally got everyone to put their names on the part is I'll go around like 5-10 minutes after all of the sheets have been passed out, and if I walk up to you and you don't have your name on your part sheet, you give me 5 push-ups, and it's enough of an inconvenience to the students that it's a little embarrassing, but it's not like mean spirited or anything, so it gives them a nice motivation to be on top of putting it on, and it's worked out pretty well doing that system. So now we're into the part where it's just down to questions, correct, Caroline?
Yeah, so now since we're finished with the presentation part of it, now is the time that we're going to ask the questions that we received from the chat. That also means for people who are watching, and if you have any questions, go ahead and put them in the chat and we'll be able to answer them. So let's start off with our first one, which is, what is the make and model of your laser cutter?
I know. So it's a Boss laser. I think it's the 2 foot by 3 foot bed. It's the basic model. I don't remember exact model name, but it's real nice having it. The one of the biggest features that I enjoy about that thing that's way better than the one that I have at work is that it's actually got an auto offset system set up, so it'll actually depth probe off of your part and then get the offset distance. Most of the time, that's good. Sometimes it does not work particularly well if the material is a little too flexible or you're doing a small part and it's able to pitch when it's pressed against. But it's a laser cutter is a fabulous tool because the software is so dirt simple. It's one of the quickest things for the students to pick up on because your variables are okay, you have a bunch of lines. Now follow those lines at this speed and at this power. That's it. And it's not like a router where you have to really worry about stuff crashing. Zatara, you did a decent bit of work with that laser, yeah?
Yes, sir.
Would you agree that it's pretty dang easy to get used to using?
Oh yeah, for sure. I want to say it takes like 10 milliseconds, and it's very quick for especially prototyping this year. If you guys didn't know, this year we made a prototype um, similar. So we called it the Wrangler. It's basically just from it's 118. Sorry, not 118. 148's buddy climbing mechanism from 2018, in which they kind of, I guess, intaked a robot from their bumpers, right? And what I'm trying to get at is basically for our prototype for creating a Wrangler so we could buddy climb, we actually just went to their public CAD and just straight up took the DXF files, slapped it right into the kind of a printer, sorry, the laser cutter, and we just replicated it one on one and then started testing that, right? So this year, laser cutter was very efficient for helping us prototype very quickly. I believe we actually got that in the first day. In the first day.
Next question.
All right, great. So the next question is, when do you switch from prototyping many varied designs to CAD for more specific prototypes?
So it's not a very rigid process. So we'll switch a prototype to CAD once we're fairly confident in our parameters. get all the dimensions, just throw them into a CAD thing, and actually start putting it onto a robot and InDesign. Sometimes that process can take a while. It basically depends on how difficult it is to prototype. If it's something that's really quick and easy to get the prototype figured out, it goes pretty quick, and sometimes we can be done with that in the first week and a half, easy. Some things will take weeks to really fully nail down, but in that process, it tends to get narrowed down so that it's we know the general shape and form, so we can start committing that to where it's going to go in the robot. But we still need to figure out the last details of how we're actually going to build the dang thing. Generally, we try and have prototypes finished by week 2 or 3. 3 would be the long running ones, really annoying to prototype shooters. I would put in that category that tends to last that long. Most intakes we have prototyped rather thoroughly by the end of the second week, and we're at that point generally very confident in putting them into the robot designs. Think there's anything else to add to that, Zatara?
I think that basically covered it. I know specifically from experience, I would just send it to actually become made or fabricated once we're I guess once I was confident that this will work, right? If it, I don't know if it works yet, we'll keep prototyping on it, and once I think it's finally ready, I'll actually get it out to be set and made, right? So whenever we think it's ready to go, that's when we actually get it fabricated.
Okay, question 3.
Great. So our next question is, can you build off the actual physical model of the prototype and remake it into a robot?
Sometimes we do. But that pretty much never happens unless we're doing a very advanced prototype where we're making very specifically fabricated components to make a near finished mechanism. This is certainly possible for a lot of teams to do it that way. It's just not the way that we typically approach it. 5458 is the other team that I mentor, and they're a little bit closer to that method. They'll make a general basic prototype, and then often the next more advanced or the one down the line after that is something that they're actually building onto a robot base, and then that stays an actual mechanism of their robot. So it just depends on how you're manufacturing your prototypes and how you are implementing them onto some sort of base. I think that's about what I have for that. If you have any clarifications, you can re-ask for that as a question, and we'll swing back around to that if you need any more clarification. Let's go with question 4.
All right, so our next question is, how do you engage new members of the team in more prototyping?
So we do the prototyping challenges, and so the groups that we have for prototyping, we have our experienced lead team member that's sort of shepherding the whole process, and then we have all the other members. So our new members are always still a part of that. We generally split them up by experience, and they are an integral part of each of these prototyping teams. So a lot of the time before kickoff goes into doing several months of training on both how to operate the machines in the shop as well as how to use all of our hand tools and just sort of the basic stuff. So basically they're always included and always trying to help. And we'll move them around as is needed to make sure that they're being utilized. Some prototypes do take a lot more people, and sometimes we'll move some of our members over. And the newer members are the ones that typically are there to help fill out numbers and hands so that there's enough people that can actually be brought to task. Go ahead and question 5.
All right, great. So our next question is, how are you able to implement prototyping virtually this year with COVID restrictions?
So that's going to be Zatara.
Yeah, dibs on that one. I'm gonna be honest. We're still working on kind of the logistics of how we're actually going to set up some at-home prototyping challenges. But we're
I'll be
thinking,
right back.
right? That's all good. We're kind of thinking of handing out some kits to our kids, like deliver them to their homes, and whatever that challenge would be, just include some materials so they can actually assemble, maybe say a project, given I guess the things that they've got, right? Um, that's a very simple answer, but I guess I can kind of talk about what our hardware kids have kind of been up to for training this year, right? So every year, sorry, in previous years, we actually have just kind of one big hardware general team, right? And eventually we'll have kids break up into specialties like fabrication, prototyping, and electrical, right? So for kind of like the past 2 months, what we've just done is not broken that up yet. And we've just kind of had all aspects of training just kind of come together and just teach them to be kind of one sign of super student, right? So what I kind of mean by that is that for all hardware kids, regardless of whether they want to kind of specialize in fabrication or electrical right now, we're kind of making sure that all of those kids will be training in kind of the design, or sorry, in Onshape, or just kind of how to design something, right? So basically, what I'm trying to get at is that we're trying to take advantage of this kind of different season to cross train everyone and kind of teach everything that we can, right? Um, some other plans that we've got in the future are to actually get our kids to have some hands-on projects. Maybe that would be like a hand tool project where they make something, or just something where they can even work on some bench working skills. Yet to do that, but in the time being, we basically have just been kind of giving lectures. We've had students kind of give examples of how they actually go about doing things. But yeah, hopefully that gives you some insight for what we've been up to in the past few months.
Great. And then our next question is, how can you be more creative in a design?
I can take a bit on this one, Devin.
Yeah. I'll see if I can
Basically,
have any ideas to add to it.
gotcha. I think the first thing that comes off the top of my head is design for the machines that you have, obviously, right? You're not going to make a mill part with some wiggity wacky, like, I don't know, some pattern that the machinist obviously cannot follow, right? So basically what I'm just trying to say is design for your machine, right? For on a mill, for example, please make,
Or hand tools if that's all you have.
yeah, or hand tools. Make like 2 parts if you have a mill, make lathe parts if you have a lathe. And I think some ways we kind of get creative is by restricting ourselves to what we call COTS components, or COTS parts or components off the shelf stock, right? And what those are obviously things like bolts, or maybe just like parts that we don't fabricate in-house ourselves, but we buy from, I guess, vendors or manufacturers, right? We design towards them and what they can make for us, right? So one example of that would be a bearing block. One way we can go about designing a drivetrain is by maybe we can make our own bearing block, but if there's already a bearing block that exists in the world, we can just kind of buy that and work towards designing around COTS components, right? And we also like designing around COTS components because their tolerances are going to be 10,000 better than ours that we make in-house, and that it kind of limits you to what you will be able to design, right? Anything you'd like to add on, Devin?
So in general with creativity, it's just it's hard to address how you just have creativity in design, but just creativity in solving your problems is certainly very valuable. It's just trying a lot of different things, but also a lot of it should be relying on past knowledge and just how to modify it into a more effective solution for what you're trying to solve. Because anything you can do to save time on complexity of just the process helps you overall become more effective at solving a challenge. So if you know, okay, rolly grabbers work really well with this type of game piece, you go, okay, let's try rolly grabbers, and then just focus on how you're using the rolly grabbers rather than figuring out what style of mechanism you're going to do for that type of thing. So just narrowing it down so that you're only picking parts of it that you're working with. Next.
All right. So our next question is, do designers produce a detailed sketch of the parts for the catters, or is it the catters, or is that for the catters to produce?
So
Yeah. So
that's part of the prototyping process. So you have to document all of the dimensions so that they can work off of that. Zatara, if you want to fill in a little bit extra on this.
that was basically what I was going to say. But yeah, it's usually people prototyping who will supply the information for the actual for the actual designer. That's basically it for that. Next
Yeah.
question, Carolyn.
All right. So our next question is, do you guys use the "Do the Math, Save the World" stickers?
Of course, 2018 robot.
We have, yeah. I don't think we have a stockpile where we can keep using them each year, but um, we definitely have put them on robots. Um, next.
All right, great. So let's do one more question. Do you guys weld anything on your robot?
Aha. We do not. I really hate welding robots for a number of reasons. One, welding can be a very time-consuming process, and it takes a decent bit of skill. There are teams that do it and do it successfully, but it's it's not a good fit for our strategy because we like hole patterns and pop rivets because it makes it really easy to change stuff all the time, move stuff around, and it just makes it more versatile. Whereas with welding, it's welded. It's very hard to take it apart at that point. The only thing I would honestly ever consider welding if we did it on 1678 would be drivetrain. We have welded stuff in the last couple years because we had no other way to successfully make a part that could withstand the forces. The what was it? The 2018 hook, I believe it was. Yeah, the 2018 hook. Man, the pandemic's really making all of this stuff blur. So the tube that went across had the hook in the middle and the two pegs at the end welded onto it around the radius. Um, because we could not come up with a way to make that part strong enough with tube, hole pattern, and rivets without it just shearing everything. I believe we also welded a part last year. Trying to think. Maybe not. So yeah, if you guys want any clarification about how I feel about welding, that's the gist of it. It's just it's a lot of process that we don't want to deal with. Um, Next question.
All right, so it actually looks like we're coming to a close with our presentation. If there are any questions that you have unanswered, go ahead and you can email. You can go ahead and email hardware@citruscircuits.org or lasgato@gmail.com, and your questions can be answered there. But let's just say
So
thank
the
you
last
to
email is mine specifically.
yeah. So let's just thank Zatara and Devin for presenting about fabrication and prototyping today, for making such a great presentation for you guys. It would be great if you guys can also check out the YouTube live chat. There was also sent out a link for a feedback survey for you guys to fill in about how this presentation went, and it'd be great if you guys can fill that in. But with that being said, let's thank our presenters, and that'll be all for our presentation. Thank you guys for watching.
Thank you.
Thank you.